All right, so I want to talk about this source I found. It's got this absolutely wild theory about our ancient timeline. And what's crazy is it doesn't start with some huge discovery. Nope, it all kicks off with this tiny little observation on an old clay tablet that, well, it just shouldn't be possible.
I mean, it sounds like a riddle, right? How could ancient Babylonians record a lunar eclipse that was only visible in America? This is the core puzzle we're going to unravel today. We've got this authentic Babylonian tablet, and it seems to be describing a lunar eclipse that, when you run the numbers today, there's just no way they could have seen it from there.
So, what gives? How is that even possible? This is where we get into the nitty-gritty. We're going to look at this one single astronomical clue that basically throws a giant monkey wrench into everything we thought we knew about history. And believe me, it could force us to rethink the entire timeline.
Okay, so here's where it gets really specific and kind of weird. The official date we have for this tablet is April 9th, 731 BC. But the details are all wrong. For starters, the eclipse supposedly peaked at noon in Babylon. Now, you don't have to be an astronomer to know you can't see a lunar eclipse when the sun is out. The moon's not even in the sky. On top of that, it was a really minor eclipse, and you could only see it from the other side of the world, like over the Americas. So you might think, okay, maybe they just predicted it. But the tablet doesn't read like a prediction at all. It sounds like they're describing what they saw. It's a flat-out contradiction.
And look, this might seem like just one tiny little error, but the implications are massive. Why? Because it calls into question the very foundation of how we date ancient history. See, these Babylonian records are what you might call our astronomical anchor.
The source we're looking at points out that if you look at records from, say, ancient Greece or Rome, their eclipse descriptions are, well, they're pretty vague. They'll say something like the sun went dark, which is cool, but it's not enough detail for an astronomer to lock in a specific date. So their timelines, on their own, are a little wobbly.
And this quote from the source really nails it. It calls the Babylonian eclipses a Rettungsanker, a life raft. They are the solid, scientific anchor that we use to pin down all of Greco-Roman history. Without that anchor, the whole timeline is just floating free. So you can see the problem, right? If that anchor is in the wrong place, then our whole historical ship is lost at sea.
So if the anchor's wrong, what do you do? How do you even begin to find the right date? Well, this is where the investigation gets really cool. It goes into full-on detective mode, digging for clues inside the cuneiform tablets themselves, and more importantly, questioning assumptions that have been around for over 100 years.
Okay, first, there's this really important concept we need to get our heads around. It's called delta T. Basically, the Earth's rotation slows down over time, just a tiny bit, so astronomers have to make a correction for it when they calculate stuff from the past. It's totally necessary. But the author of this source argues that sometimes it's used less as a precise correction and more like an astronomical fudge factor, a way to force the data to fit a historical record, even when it feels like a stretch.
And this slide is a perfect example of what they mean. Check out this famous eclipse from 1306 BC. If you just calculate its path, no funny business, it passes over Spain. It's thousands of kilometers away from Babylon. To make it match the Babylonian record, you have to apply a massive delta T value, which basically just drags the eclipse path all the way across Europe to the Middle East. It raises a really good question. Are we making a valid correction here, or are we just forcing the puzzle piece to fit?
All right, that's clue number one. Clue number two is honestly even crazier. It has to do with the planets. So when these ancient tablets list the planets, the standard translation gives us an order that makes, well, no sense at all. It's like Jupiter, Venus, Mercury, Saturn, Mars. It seems completely random, and historians even admit they have no idea why it's in that order. So this led the investigator to ask a huge question. What if we've been translating the names of the planets wrong this whole time?
And here's the proposed fix. It's a new planetary code. The idea is, what if the Babylonians weren't listing them randomly? What if they were listing them in a perfectly logical order, based on how long it takes each planet to orbit the sun? You know, their orbital period. If you rearrange them that way, you get a totally new translation key. The cuneiform symbol we've been calling Jupiter might actually be Mercury. The symbol for Mercury could be Saturn. It's a mind-bending idea for sure, but all of a sudden you have a logical system instead of just random chaos.
Okay, so this is where it all comes together. This is the big reveal. We've got two huge clues, right? First, the eclipse paths seem to be forced to fit. And second, we might have been translating the planets all wrong. So the author takes these two clues and uses them to test a really wild hypothesis, putting that eclipse from 1360 BC right under the microscope. So just to quickly recap the problems with that official 136 BC date. The eclipse path is way off without a massive fudge factor, and on top of that, even with the correction, the planets that the tablet says were visible don't quite line up with what our modern software says should have been there. Things just don't fit.
So the proposed solution isn't to just keep tweaking the numbers. It's way more radical. The hypothesis is, what if the event didn't happen in 13.6 BC? What if it happened 1,135 years later?
And this is the incredible part. When you plug in this new date, April 7th, 1000 AD, the source claims that everything just clicks perfectly. Step 1, in 1000 AD, there was a total solar eclipse, and its natural path went right over Babylon. No fudge factor needed. Step 2, the planets that were visible, a perfect match, but only if you use that new planetary translation code we just talked about. Step 3, a super specific detail about where Venus was near a certain star. It also matches the 1000 AD sky. And step 4, there's even another mention of a lunar event on the tablet, and guess what? It lines up with a lunar eclipse that happened just 2 weeks before the solar one. Suddenly you've got 4 different independent astronomical markers all pointing to this one new date. It's pretty compelling.
And now, here comes the domino effect. The tablet dates this eclipse to year 175 of the Seleucid era. Now, if year 175 is actually 1000 AD, well, you can do the math. It means the entire Seleucid era, which is a cornerstone calendar for the ancient world, didn't start in 311 BC like it says in all the history books. It would have to start 1,135 years later, in 825 AD. One single change to one eclipse date, and you're basically rewriting a huge chunk of history.
And just when you think it can't get any weirder, there's this little kicker that adds another layer. That new proposed start date, 825 AD, it's not just some random number pulled out of thin air. It just so happens to be the exact same starting year for the Malayalam calendar over in India, and the origins of that calendar are still a big mystery for historians. Is that just a wild coincidence? The source suggests maybe not.
So, at the end of the day, what this whole thing shows us isn't about proving 100% that all of history is wrong. It's more of a thought experiment, really, but it's a powerful one. It shows how our entire picture of the ancient world can be balanced on just a few tiny points. The translation of a single word, the interpretation of one eclipse. It really makes you step back and ask a bigger question, right? What other facts that we all just accept as true are maybe, just maybe, built on a single interpretation from a long, long time ago that no one has ever thought to question?